Welcome to ClickMyProject.com. Now we will discuss about adding geospatial data provenance into SDI, service-oriented approach. The geospatial data provenance records the derivation history of geographical data product. It is important in evaluating the quality of data products. In a geospatial web service environment, where the data is often disseminated and processed widely and frequently is in an unpredictable way. It is even more important in identifying original data sources, tracing outflows, updating or reproducing scientific results, and evaluating reliability and quality of geospatial data products. The geospatial data provenance has become a fundamental issue in establishing the spatial data infrastructure. The paper investigates how to support provenance awareness in SDI. It addresses key issues including provenance modeling, capturing, and sharing the SDI enabled by interoperable geospatial services. A reference architecture for provenance tracking is proposed, which can accommodate the geospatial feature in provenance at different levels of granularity. The open standards from ISO, the World Wide Web Consortium, the OGC, are leveraged to facilitate the interoperability at the feature type level. The paper proposes extensions of W3C provenance XML for ISO 9115 lineage and parent level provenance registration. The geospatial catalog service at the feature instance level, the lightweight lineage information entities for feature provenance are proposed and managed by Web Feature Service. Experiments demonstrate the applicability of approach for creating provenance awareness in an interoperable geospatial service-oriented environment. Now we will see flow of our process. First of all, we have selecting the geographical data, which contains different classes such as state, lake, river, mountain, high point, low point, such like that. After selecting the dataset, the dataset in the audio format, and the dataset type is ontology web language. The dataset is parsed and applied to preprocessing. Preprocessing means we have extracting the objects from classes. After that, we have constructing the multi-level graph. In multi-level graph, in multi-level graph contains the set level and source level. In set level, we have finding the relationship between input keyword and attributes. And the source level, we have finding the relationship between keyword and attribute and relational table, and to find out the recover relevant path and find out the score for the relevant path and applying the IR style ranking, and finally we have getting the relevant source. Now let me see demo of our process. First of all, we have to run homepage.java. First of all, we have to select input dataset, that is geographical dataset. The format is OWL. OWL means ontology web language, and the ontology type is RDF. RDF means resource description framework. After that, we have getting the RDF class, RDF properties, and the data type properties, data type, object type properties, and parsing the object. The object list of state, table, river, high point, low point, mountain, road, lake. After that, we have performing the parsing object, parsing the each class. After that, we have store the values into the database. After that, we have entering the input keyword, such like that. In set level and source level means set level means the attribute level. Attribute level we have getting the relational data, the keyword related to attribute, and source level we have getting the relevant information in source level. After that, we have to find the number of paths from source to destination. And we are getting the ranking. And finally, we have getting the relevant source for geographical for input keyword. The relevant source is state. The Alabama is state. Finally, we have comparing the existing and proposed solutions. Existing and proposed comparison, we have taken the parameter of time, execution time between existing and proposed system. Thank you. Thank you.